Okay, fine. So it seems like most of the guys are here, so we'll get started. First of all, I'd like to welcome you all along to the second webinar, our Q&A webinar. We've been looking at the questions you sent in to our virtual formula email address. So first, I want to cover the questions we've received, and then after we've covered those questions, we'll open up the questions to any of you guys out there at the moment. So, first of all, the one big question we got, which I for sure want to make sure you guys are 100% correct on, is regarding the rules and regulations. We were asked whether the rules are the same as the official FSAE rules, and the simple answer is no. The long answer is what I'll explain now, is basically that the rules we've created are based on the FSAE rules. But the idea, of course, is to make it a much, much simpler version of the real competition. So if we go to our download package, we have our rules. And then if we get through all the event description, we see here we have the model restrictions. So for those of you who are already familiar with the official FSAE rules, you'll recognize some of these. For example, the wheelbase must be 1525 millimeters. Suspension travel must be between these amounts, and so on. What I'm going to do now is basically go through each one of these rules and then show you what exactly they mean in terms of car real time. So if I grab car real time and put them on the left, we can see both things at once. So if you look at the rule structure, you see that we've divided each rules into each of the car real time model subsystems. So you have the body, the brakes, the suspension, so on. We've laid it out this way just to try and make it easy to see what each rule exactly is applied to. So if we go through the list, we see the wheelbase must be at least 1525 millimeters. So pretty self-explanatory one. If you just find this under sprung mass, you see here wheelbase. So we see our example car is legal so far, so good. This also means, of course, you shouldn't be changing any of these values down here, and the masses and the inertias and the CG point, these should all stay fixed as you received. Then you see the next rule is regarding the downforce sensors. So if we move over to aerodynamics, we find these are here. Down here you see front and rear sensor location X, Y, Z. And here it says they must be the same as your ride height sensor locations, which can be found in your suspension and then in your suspension setup data you see here. The reason we've defined that your ride height sensors and your downforce sensors must be the same is because the aero map we're using is ride height dependent. So if you move back to your aerodynamic forces and you click on this little edit button, you can open up the aerodynamic property file, and then you can go down and see exactly what force you would be getting depending on your ride height. So you see we have a block for the front downforce, a block for the rear downforce, and a block for the drag. So just for your information, if you want to read this table, you essentially have this first column for front downforce is your front ride height, as it says here. So that's this column. Then you see all of these values to the right of this column are downforce values in Newton. Then up the top here you see the rear ride height in millimeters. So if you want to read this, essentially you just take this column and you transpose it along the top here. So for example, if you wanted to see what downforce you would be getting Can everyone hear me okay, or just the one? It's fine here. Okay. Okay, fine. Well, it seems everyone can hear more or less. So we'll carry on. So you see here on the left you have, wait, where was I? I'll start again. This column here is your front ride height. Then if you take your rear ride height column, put it along the top here as a row, and then you just read off the table. So if you had 100 millimeters front and rear ride height, you'd get 85 newtons of downforce at 40 kilometers an hour. Obviously then it extrapolates this data to calculate your downforces at various speeds. So then we have the rule stating the downforce modifier scale. So if you're unsure where this is, you stay inside aerodynamic forces, you move to this modifiers tab, and you see here we have front and rear downforce, and on the right hand side we have a column for scale. So these are the values you're allowed to adjust. You can see here we specified the range. You can adjust them between, so plus or minus 0.1. And then we also stated that the total of these two scales must equal 2. So you could have, for example, 0.9 and 1.1 is your maximum, or alternative 1.1 and 0.9, and everything in between. As long as these do equal 2, and they're between 0.9 and 1.1, you're fine. So, for those of you that are paying attention, you might have noticed that the rear downforce you actually have more of compared to the front if you compare the values. This means that if you were to set up your modifiers like this, so you multiply the rear by 10% and reduce the front by 10%, you actually gain a total downforce. However, of course, this moves your downforce further to the rear. So maybe it's an area worth looking into, but maybe the trade-off is you have more total downforce, but you've moved the aerobalance too far back and you're now understeering massively in the faster corners. But something worth looking at. Now if we move on to the brakes rules, we can just move into the brake subsystem, and you see here, if I drag this over, the only two values we can change here are the brake bias and the pressure cylinder gain, the master cylinder pressure gain. So the bias front is quite self-explanatory. It's a simple percentage. So at the moment we're running 55% of the braking at the front wheels, and the limits are stated here. So you could run between 20 and 80% to the front. I don't expect you guys to be running such extreme brake biases, but I thought we'll see what happens. Then you have the master cylinder pressure gain, which is this value here. This essentially defines how much pressure you get in the brake system for a given brake travel. So if you were to double the pressure gain to 0.2, you would effectively get twice as much brake pressure for the same amount of brake travel. Or alternatively, you would get twice as much or half as much brake travel for the same amount of pressure. Moving on to the suspension rules, we see the suspension and steering geometry can be created using suspension gen. Alternatively, it is possible to create suspension through Adam's car. So if you guys are more comfortable with that or already have a suspension in Adam's car, you can export your suspension from there directly into VI car real time. The process to do this is a bit detailed, let's say, not something I can cover in 5 minutes. So we will plan to release a short tutorial video explaining exactly how to do this in the coming weeks, maybe hopefully by next week. But to be honest, VI suspension gen does most of the things you want. So then you see the second rule is we must use kinematic analysis when exporting the suspension. So if I get into VI suspension gen by loading our example suspension using this little shortcut, then finding rules and regulations, okay. Here we see in the bottom left we have the kinematic analysis or an elasto-kinematic analysis. The difference between these two is the kinematic analysis is, as the name suggests, it runs a purely kinematic test to create these splines. So there is no bending or deformation in the joints of the suspension. It's a completely rigid system. In reality, of course, your suspension is not completely rigid, so you would run elasto-kinematic analysis, but this would also mean you need to have good definitions of the stiffnesses of your entire suspension layout in terms of linear, well, in terms of translational stiffness and rotational stiffness, and it all gets much more complex, much quicker. At the same time, the car we're running is very light, so we wouldn't expect to see huge amounts of deformation anyway. So for the argument of simplicity, we've decided that it's much easier just to run a kinematic analysis. Then we see the following rule is the smaller track width must be at least 75% of the larger track width. So you can estimate your track width inside suspension gen by simply taking the wheel center position in Y and doubling it. So we see we have 700 here. If we move back to car real time, and we select on front suspension, we see in the first tab, the wheel location, we have our track width, and it's very close to 1400. So if we wanted to check our rear suspension is within this rule parameter, we can see, of course, we're pretty much running the same track width front and rear, we're fine. Alternatively, if we wanted to know the maximum rear track width we could run based on this front track width, we would simply just divide this number by 75%, so 0.75. Then moving on to suspension travel must be at least 25.4 millimeters for both jounce and rebound, for a total of more or less 51 millimeters. This doesn't mean you necessarily have to be using this entire range during your runs. It just means that when you run your suspension kinematic analysis, you must be running between or over this range of wheel travel. So essentially means this value for jounce start and this value for jounce end must be at least 25.4 millimeters, plus or minus. Then we see the springs must be set to a linear rate. The same is true for the dampers. So if you want to check this is true, you would go to your springs tab, you would go to the property file, and you would select linear. When you create a suspension gen suspension and export it, by default, your suspension property file will be set to non-linear. However, if you click the spline, you'll see that, in fact, the spline is linear. This is because you predefine your stiffness of the spring inside the general data. So you see down here we have K-spring. Also, the same is true for the damper. So they both export as splines, even though they're linear. So you'd simply just move to your springs tab, move to property file, and select linear, and you should see the same rate. Then, of course, you can just tune your spring rates and damper rates very easily this way, setting linear. Then we see the anti-roll bars must be auxiliary, which means you have to be using this auxiliary anti-roll force system. To get this tab available, you must export your suspension with this moving over to anti-roll bar data and checking at ground. This was covered in the first webinar we did, but just a quick reminder. If, however, you forget and you export your suspension with elements, like so, desktop, working directory. I already did this morning, so we'll overwrite this. Okay. Now if I load my suspension again, and select it, you see now up here we have anti-roll bar instead of auxiliary anti-roll force. So what this is essentially doing is it's going to put the force through the design of the roll bar here. We want to say anti-roll bars must be auxiliary, which means it actually skips out modeling this anti-roll bar and simply applies the roll stiffness at the wheel contact patches. So it's a much simpler solution and a lot easier to tune rather than having to worry about the layout of your anti-roll bar elements. If, as I was saying, if you've created a suspension and you've got it set as an element and you want to change it to auxiliary, there's two ways. The obvious way is to load your suspension, go to anti-roll bar, set as ground, and then re-export it. Alternatively, you can find your suspension subsystem file. So if you go to where your file is saved, so we have, for example, if I go to date modified, here is our new suspension. If I open this with a text editor, you see in here we have the full description of what you essentially see in the car real-time GUI as this folder. So we can see, for example, luckily the top section is actually the anti-roll bar. So this 2642 lines of code represents this tab. So instead of creating a new suspension, we can simply replace these lines with an auxiliary anti-roll force line of text. So if we take and also open our original suspension in the example model, we move to subsystems, we find front suspension, we edit it, we see instead of it saying anti-roll bar, it says CRT auxiliary roll stiffness. So if we drag to the end, you know you've got to the end of the block because it says the name at the start at the end. So here we simply want to copy this part of the code and overwrite what we have here. So now we have auxiliary roll stiffness. Then just simply save, go back to car real time, reload the suspension by pressing this little refresh button. Then we move back and we can see here now we have our auxiliary anti-roll force tab set to the same settings as the other suspension we stole it from. So, okay. Then we see static ride heights must be set up correctly. This was covered again in the previous webinar. So hopefully you guys are familiar and comfortable with having to set this up properly. If you're ever unsure of if you set it up correctly, you can just simply email us at Virtual Formula. Support email address, I believe it's virtualformula@vi-grade.com. Then finally, you can set up your wheel, toe and camber angles freely, which is found again inside your suspensions. So suspension setup data, and you see here, you have these little check boxes which you can check and then define your toe and camber angles. I will quickly go back to the original front suspension. And then I'll explain how these are applied. So when your simulation starts, you may have noticed that it loads the tires, or I can show you as I explain, to be honest. So if I run this, we can see everything initializes. It initializes the tires, does the driver, solves for static equilibrium. Then if I scroll back up, solves for static equilibrium. Then it performs the vehicle setup. So at this point, it applies the settings you've defined here. So it applies camber angle, the toe angles, it applies your ride height correctly, and so on. And then once it's applied all of your settings, so it's essentially set up your car, it solves the static equilibrium again at the start of the simulation, and then setup is complete, and then it runs. If you want to investigate the effect of toe and camber angles, there's two ways. The obvious way is to simply create a bunch of tests like cornering and acceleration and so on, and trying different camber angles and seeing what happens. Alternatively, we have a tool which is quite useful inside here. Inside utilities, we have a tire test rig. So what this is essentially a virtual version of the real test rig you have, where you put a tire on a rig and then you load it. In a certain way, you can give it camber angles, certain rolling speed, and so on. So this essentially does this virtually. So we select the tire property file. We go to the VI Racer database, select the tire file, and then up here we have the analysis data. So these tires now are based on the Hoosier tires we got some data for a few years ago, I believe, but now they've been modified to try and make it each year the competition on slightly different tires. So the guys from last year are not having too much of a head start on the guys from this year. So if you want to set up your analysis using, say, your camber angles, your velocity, the toe amplitudes, this is the range through the slip angle. So essentially you go from -15 to +15 slip angle, and the load. So if since we have quite a light car, reduce the load somewhat, we're not getting up to super high speeds, so 10 meters per second is maybe okay. Then we define our file name, so we can call it lat camber 0. And if we make sure post-process is still checked, we can run. And this will automatically load up the iAnimator and the results, which you can see here. So if I drag this down to fill the window, we can see you should get something that looks like a tire force slip angle curve that I'm sure most of you guys are familiar with. So we see at 0, we have more or less 0 lateral force as expected, and then as the tire slip angle increases, the force increases up to a certain slip angle where it tapers off. Then this is for lateral force, by the way. So you see up here we have Fy is lateral force versus lateral slip, and you have the turning moment of the tire. You can see here. It's not so important for your virtual driver because he doesn't actually have any arms, so he doesn't get so tired if the forces are big. Then you have longitudinal force versus longitudinal slip. In this test, we're not looking at longitudinal slip, so this will always look weird. We're focused on pretty much this first tab. So now if I want to check the effect of running 5 degrees of camber, we can select 5, and then rename ourselves 5, deselect post-process results and run. Otherwise, you'll open another animator window, and if you do that every time, you end up with like 10 animator windows. So instead, we just want the one, and then we can come up to load. We can find where we're working. And if I sort by date again, we can see our new results. We can plot them in. So you can see here we have an initial camber thrust offset, and overall we have a larger peak on this side and a smaller peak on this side. One thing you need to remember is the side of the tire, how it's defined in here. So I remember correctly, this is a left side tire. If I scroll down, you see tire side left. This means in this situation, running positive 5 degrees of camber on the left wheel when you're turning left, is you have a negative slip angle, and you have the camber going into the corner you're turning, so you get this extra force. And then you have the opposite is true on this quadrant down here, so you actually get less force because the camber is working against you. If, for example, you plot -5, so some of you might be thinking, why is he using positive? It's just for convention's sake, I prefer to have this top half is my good window, if that makes sense. If I run -5, you should simply flip over this spline. So if I run this, you see now this bottom half is the good part. So you just need to remember exactly which part is what you're looking at. So if I run that again and reload, we see this. So if we're running -5 camber, we see we're gaining, of course, on the outside tire. Then, however, if we look at the longitudinal force, I'll just keep the same naming convention, even though it's not particularly right now, just so they stay loaded, and run. And then run again with 0 camber, and rename this as 0 and run. And reload, and move to our longitudinal force versus longitudinal slip. We see now that, as expected, running with no camber, you get more longitudinal performance under braking compared to running 5. So, as you can see, that there's a trade-off you have to make. You can either run huge amounts of camber, which gives you lots extra force in the corners, but sacrifices force in the straight line, or you can go the opposite direction and run no camber, or you can try and find the balance in the middle. Okay, so went a little bit off track just then. If we move back to rules and regulations, we see, okay, so we got to the wheels, no adjustments permitted. It's a pretty simple rule. If you go inside here, you don't change anything. You can see here's the data for the tires, the wheel masses and inertias. None of these should be changed. Then moving down to the powertrain, we see first the vehicle must be all-wheel drive, therefore all the differentials must be active. So then you just go to differential and you see all of these should say yes. If you want to go inside any of your differentials and change the settings, you simply double click on the one you want to look at. So front, double click, you see you're inside the front differential now. And here we see you can choose between open and LSD, so that's simply these two settings here. With open, of course, you have an open differential, there's not really any settings to change. With LSD, you can change the preload and so on, your spline for how it works, your extra coefficients. If you're ever unsure on what any of these things mean, you can go in up to this help and load the printable documentation, and then either use this little index to get around to the car time framework. There's also extra tutorials in here if you want to get more familiar with the software outside of what we've been showing you in the virtual formula. And if you want to find something specific, just use the Control F and find function and find whatever you want to find. So everything you want to know about car time is in this document. Then we see, yeah, Noah is great. Make sure you print out the entire, however many pages this was. 887, yeah, sure. You might as well print it off twice just to be safe. So, moving back to the transmission, we say you can move between a value of 10% to 9% front drive bias, so you can either run with only 10% power at the front or almost all the power at the front. I'm sure you guys will work somewhere more in the middle of these ranges, but you never know. And then you see the transmission ratio must maybe freely adjusted, so that's this value here. Since we've decided we're emulating an electric vehicle for this competition, we've decided that only one gear is allowed, so you see reading on your You cannot change the number of gears or the gear ratios. So these are the values in here. You shouldn't be changing anything in here, just the outside transmission ratio, which effectively works as your final drive. And then, yeah, anything, if you're ever in doubt, anything you don't see in here, you shouldn't be changing. And then if you're still not sure, just send us an email. Then, quickly, since actually running over time a little, one other question we got was on the technical report. So if we move up here, we see one of the events is indeed a technical report. What this essentially is supposed to cover is, we don't need any of these, is you're supposed to essentially just describe the process of your optimization. So if I find, should be on the desktop actually. Here it is, okay. So here we have a draft copy of the template. Ooh, kind of big. The official template will be released soon. Yeah, as Noah said, it is worth, I believe, 50 points this year. So yeah, 50. So I think there's a breakdown here somewhere. Yeah, here we go. It's 50. So it's not worth the most of. It's worth the least out of all the events, but 50 points is still better than no points. So it's worth doing. But as I'm about to explain, it's not the most technical report. We're not expecting you to write a thesis, essentially. So here you can see straight away the report should be no more than 10 pages. This is including plots and tables and images, so that's not 10 pages of text, that's 10 pages total. Then you have 5 separate titles. So you have team details, I'm sure that's no problems, objectives, and then most of the content of your report will be based on the modeling or the optimization process you've decided to follow to optimize your model, and then your results and a brief summary. At the end here we have still in draft a scoring process, still subject to change, so whatever you see here, don't take it to heart straight away. Hopefully by the end of the week again, we'll release the official template and scoring system. But for the most part, your scoring will come from the content of the report. So this is things like describing what your objectives are, the optimization simulations you ran for cornering, acceleration, braking, efficiency. Then also the design decisions you've made based on the results of your simulations and with reference to your objectives. And then finally, logging the results you've got. So that will be the vast majority. Currently we're seeing 30 out of the possible 50 score is based just on purely content. Then we're planning on awarding about 10 points based on your knowledge. So this is knowledge of vehicle dynamics and simulation, specifically car real-time simulation. So to break this down even further, this is basically your ability to identify and solve the vehicle model weaknesses. And then in terms of simulation, are your tests suitable for the performance area of interest? So if you want to improve the cornering of your car, are you setting up the right sort of simulations to analyze the weaknesses and so on? And then, of course, do your decisions based on your simulation results make sense? And finally, your ability, again, to run various simulations. So not running the same simulation for everything, but of course, we don't expect you to run all the simulations possible just for the sake of it. And then finally, for the same amount of points, the presentation. So this is always important for reports, is to make it super easy to read, super clear. All your plots need to be clearly labeled and annotated. Again, ideally, I should be able to look, or we should be able to look at a plot and immediately, or almost immediately, understand what exactly we're looking at and what the results are. So that's the first two checked off. In terms of future videos, as I mentioned at the start of the video, it's not actually written here, but we'll plan to do the Adam's car suspension export-import process. Then another useful process to learn for optimizing a vehicle is to do an optimization sweep with MATLAB. So this is a way of running the same simulation over and over again, but changing one specific or more specific parameters automatically. So you predefine, for example, if you wanted to see the optimum gear ratio for doing the acceleration test, you could set up the acceleration event and then set up some gear ratios you want to work between. So you can run between a gear ratio of 3 and 5 with intervals of 0.2. So that's like 10 different simulations. And then MATLAB will automatically run these one after another super quickly. So for optimization, this is a very useful tool. Then we have how to submit your model and results. So again, this is quite an important one. yeah. True. Noah's upset because everyone's knowing all the secrets now. Okay, yeah. So we need to also release a video for how to submit. It's quite an important thing, how to submit your model results. It's not such a complicated process, but I figure a 5-minute video should cover it in detail. And I think that's it. So since we have about 15 minutes to spare, we can open up the questions to the guys in the audience right now. Either go for chat or unmute yourselves, and we can do it audially. I don't think that's a real word. Cheers, Noah. I thought that, yeah, the videos, as they say, an image speaks 1,000 words, makes sense. So it's not so long ago I was like you guys, where my knowledge was minimal on the subject of even simulation in general.
So I've got a question regarding just things to worry about with the steering system. So like when you're modifying kinematics and you import, just is there, you know, sometimes either for our model or for when we're modeling our own car for our drive sim, you know, there's all these different parameters in the steering system that you're not sure if you're supposed to be modifying or if you accidentally modified, etc.
Okay, so if I move to the steering system, you mean if you can guide me maybe? Which parameters exactly are you talking about?
Just kind of like, I get, so with this competition basically, we shouldn't be touching any of them, correct?
Yeah, basically, once you export from suspension gen, then there's not really any need to change any of these. However, if you wanted to drive your model for real, of course, as I said earlier, you have you want the feedback to be correct, so you need to be setting up your tie rods correctly, your assistance, if you're running any assistance. I assume on the former tuning cards you're not really running any assistance because they're quite light. Your steering ratios are obviously very important in reality. You don't want to be doing 720 degrees of steering at the wheel to get 1 degree of steering at the ground.
But the car real-time driver, none of these end up affecting him, right? So this is only...
No, not at all.
Okay.
Yeah, he knows exactly what's going to happen.
Okay. So there's no reason to really play with these settings either, because it's like, oh, if you set it to 720 degree steering lock, he'll be so much more precise. No, he knows what he's doing regardless.
Yeah, no, I think he goes to a limit of 900 in both directions. So as long as you're within 900 degrees all the time, then yeah, you're fine. If you want, of course, you can try these things out and see if it actually makes a difference. In my experience, I haven't noticed anything.
All right. same thing goes for brake pressure. Like,
Yep.
since the driver like knows what he's doing, does master cylinder pressure really matter? Like, I know bias, it makes a huge difference, but
Yeah. With the master cylinder, it only matters if he's not able to use all of the braking. So, for example, if you don't have enough gain, he'll be using 100% of the brake, but not using all the possible braking torque. So he won't be able to actually lock up the wheels. So the only time you ever want to worry about pressure gain is when you're too low. For example, if I look at a result of the autocross, you can plot your driver demands. So you see in here, if I get rid of the throttle, we see he has a maximum of 80 here, so that's fine. If, however, you reduced your braking pressure, you would see he was peaking at 100 very often, like
right.
sort of a cutoff. In those periods, he's not able to use all of the braking. In that case, you would need to increase the pressure.
Mm-hmm. Okay.
But yeah, as you suggested, the steering and braking tools are very useful for real development when you've got a real driver. But the virtual driver, as I said, he doesn't mind if he's only using 10% of the brake travel.
Right. We got another question if no one else does regarding powertrain. So even though in like the gear ratios tab you have access to 4, but you know shifting isn't enabled. We're not allowed to enable shifting. We can just change the overall.
Yeah.
Right. So we're only allowed to change transmission ratio. We can't go into. We can't enable gear shifting, I should say. Right. We're only supposed to use.
Yeah. Essentially, the idea is to have one gear. So I think for the most part that seems to be the general strategy in competitions with electric vehicles.
Yeah, last year there was a pretty fun, some weirdness involving gear ratios that made acceleration pretty easy.
Okay.
In the virtual competition.
Yeah, I think there was a few weird things at the last competition. I remember seeing, because I received the last year's model as the base for this one, I remember seeing some issues with a few things, specifically the tyres were quite strange. So hopefully this year the tyres make sense.
There's a lot of things that are weird. Like, last year, I mean, I can tell you guys now because it doesn't matter, but, like, to do the best on acceleration, the guy started in first gear, and first gear was, the ratio was higher than second gear, and so he would start and he would immediately kick down to a high RPM and just take off.
Okay. Nice, like launch control. That's a good idea.
Yeah. I had no business being in second place last year, but I just found so many different things.
Found all the little secrets.
Yeah.
Well, I've given away all the secrets this year. Maybe, unless you found some more.
No, it's about all of them, but it's helpful because last year they basically threw it at us and we're like, all right, good luck, figure it out.
Yeah.
And what that essentially meant is, although I was super interested in it and able to spend hours upon hours doing all this crap, I was never able to convince any of my other team members to.
Okay.
So hopefully now that everything's spelled out a lot easier, I can throw it off to some of the freshmen and say, hey, it's not that difficult, just because the manual's 900 pages and you haven't had time to read it. Like, it should be fine.
Yeah, exactly. It's very, I guess we can easily fall into the trap where, because we know it, we think it's fine, but then someone who's never even seen the software before is like, what's this?
Kind of intimidating.
Okay, fine. So, anybody else with any questions you want to come in with?
There's one in the chat.
There's one in the chat. Ah, yes. Good chat. I've got my chat hidden. Okay. Do the suspension hardpoints have any constraints? For example, could I have... we haven't defined any constraints. didn't actually quite think about this, to be honest. Obviously, having your center point in the very center of the car is maybe not the most realistic solution. But since it has not been defined as a constraint, I guess you're completely free to do what you want with your hard points. We'll see what comes out. Yeah, see. Does the indicated ride height affect the CG of the vehicle? That entirely depends on if you've set up your ride height sensors correctly. So the ride height you see in Animator, if I still have this loaded, and I load ride height, you see these are my ride heights as I go around the track. However, if I change my my sensor locations, actually, well, 1 second, I'll set this up easier, more obvious to explain. So if I close this, open my acceleration event, and then I'll change the sensor location and run the acceleration event again. Front suspension, suspension setup. If I change this to 0, 0, and also this one 0, and I copy and run. In this scenario, we should see that the ride height should be more or less the same. They'll be affected by aero forces, of course. However, we should see a bigger difference in the CG position. So this is done. So now if I do this way, so select both of these. So not sure if I covered this. You want to compare two results. Is you can select one and then control, select the other, and then right click and execute, or use the little film reel at the top. This will load both the results. Then if I plot ride height, so front ride height, we see they look quite different. When you look at the scales, they're very similar. The difference we see here is mostly due to aerodynamics. Actually, why don't we just use the full screen? Then if I also plot CG height, we should see a much larger difference. So CM to find the center of mass of the chassis, we plot global Z, we see we are offset by much more than our offset in terms of ride height. So to come full loop and back to your question, does the indicated ride height affect the CG? As I said, it depends. If you've got your sensor set up correctly, obviously changing this ride height value moves up and down your CG. And you will see these changing here, the ride height accordingly. If you have your sensors set up incorrectly, your ride heights may look correct, but your CG position will be either too high or too low. Hopefully that answers your question. I ended up in a bit of a loop.
Yeah, it does. Thank you.
Okay, fine. So we probably have time for one more quick question, if anyone's thought of anything.
In the rules or program, is there a limit on the track width of the vehicle?
In the rule, there's only a limit on the minimum
only the ratio.
track width. Yeah, the ratio is the 75%, and also the minimum is, I think. Wait, no, sorry, that was wheelbase. Yeah, you're right. There's no rules, but yeah, of course you have to stay within the track limits of the road. So somewhere there is probably a balance.
So CG height can't be modified. Can you might have covered this because I came in late, but can front to rear CG longitudinal distance, can that be modified this year, or did that get changed?
No, we scrapped that, because last year you did, I'm getting a bit of echo off you, no,
Oh.
No problem. Yeah, so to carry on, last year I believe you couldn't change, but you could add some ballast to move the CG overall that way. This year we've decided you must keep this default. Of course, by adjusting your wheelbase, you end up moving your weight distribution in that manner. So, for example, if you make your wheelbase really long, since this value doesn't change, you're actually putting more weight distribution towards the front. So, by default, I think we're more or less on 50-50, more or less. So, basically, you can make the wheelbase longer to move it forward or make it shorter to move it back, but it doesn't seem you can go much shorter. Okay, apparently you could change CG depending on ballast. Okay. Well, this year, no, you can't. You have to work with what you got. Exactly. It would be too easy if you could just move the weight distribution perfectly. Okay, fine. So, thank you everyone for coming. The questions have been greatly appreciated. As I said, we'll be coming out with some more tutorial videos and more information in the coming weeks. I hope this session has been useful for you guys. Again, just like with the last webinar, we have recorded this one, hopefully, if I remember to press record. And this will be uploaded again in probably by next week, hopefully, for you guys to review. And of course, as always, if you have any more questions or anything regarding the competition you want to ask about, you can always send us a question to, I believe, virtualformula@vi-grade.com. Okay, cheers everyone. See ya.